This is your Unit 5, Lesson 3, Day 4 homework. I'm finishing up the review questions right now, and I last did questions 32 through 34. Today we're going to do, or in this one we're going to do questions 35 and 36. So this is question number 35, found on page 389 in your textbook. That's Core Plus Mathematics, Series 2, Course 3. So Part A asks us to solve the expression 2 to the x equals 8. You might look at that and go, well, I know that 2 times 2 times 2 is 8, so that x must be 3. I know that, but if we're going to use algebraic skills, I would probably say let's use logarithms. So if you use a logarithm with the same base as the base of the exponential, then those two are going to be inverses to each other, and we can cross them off, leaving x equals the logarithm of 8 base 2. Well, if you don't have the Inspire, you have a different calculator, you can actually type this in as a logarithm of 8, the common logarithm of 8, divided by the common logarithm of 2, and get the same answer that x is equal to 3. So that's the first one. In Part B, we're given that 2 to the x equals 1 over 16. Well, automatically I'm saying something about, a 16th, a fraction. So this is probably going to be a negative expression. So I can do the same work I did in the previous part. Logarithm base 2 of 2 to the x equals logarithm base 2 of 1/16th. And I'd find these cancel off, and I get x equals. But here's the great part. I do know a little bit about how to find this without actually needing the calculator. I know something about 2 and 16. 2 times 2 is 4, and I know 4 times 4 is 16. So if I think about it, I have 2 times 2 times 2 times 2. That's 2 to the 4th power would be 16. But since it's 1/16th, it's going to be a negative 4 as an answer. Kind of neat. All right, in Part C, we're given that 10 to the x equals 10,000. So here again, I look at the count of zeros, 1, 2, 3, more zeros in the 10, well, 1, 2, 3, 4 total. So this is actually 10 to the 4th power. Now I could use a logarithm base 10 of 10 to the x and logarithm base 10 of 10,000 and get x equals 4. Okay, and here I have 10 to the x equals 0.12345 zeros and a 1. Okay, so we're dealing with something that looks like tenths, hundredths, thousands, 10 hundredths, 100 thousandths, millionths, 10 millionths. Looking at the 10 millionths place here, okay, which I know is going to lead us to a negative x value as well. But if I do logarithm base 10 of 10 to the x, and I do logarithm base 10 of 0.0000001, I'm going to get an x value of, well, really just have to count how many places you've moved the decimal point. So we've moved the decimal point 1, 2, 3, 4, 5, 6, 7 places to the left. So this is a negative 7. Okay, that ends 35. 36. Express each of the sums or differences as a single fraction in the simplest form. So I begin with 1/8 plus 5/8. That is equivalent to 6/8, which is 3/4. In Part B, I have 4/5 minus 2/3. I need a common denominator. A common denominator will be the 15ths. If I multiply this by 3 over 3 and this by 5 over 5, I would get 12/15 minus 10/15, which would equal 2/15. I'll circle my answers on those two. And then Part C of this expression reads 1/3 plus 5/6. I notice here that the sixths are just twice as big as thirds, so if I multiply this by 2 over 2, I would get out that 2/6 plus 5/6 would be 7/6, which I'm going to leave in this expression. But some of you are going to be really tempted to say that's the same as 1 and 1/6, and that's fine, but we're going to spend most of our time talking about improper fractions when we deal with rational functions, so we'll leave it like that. Part D is going to read 3/10 minus 7/6. Need a common denominator, and we generally try to get the lowest common denominator, so what I'd actually like to do is get this to 30. So to get this to 30, we'll multiply by 3 over 3, that becomes 9/30ths. And then on 7 and 6, we actually have to multiply by 5, so I get 35/30ths. I'm going to subtract these two. I get 9 minus 35. Well, we're dealing with then a negative 26. Okay, and then 30ths. And even there I see, wait, I can still divide this by 2, right? So if I do this and divide by 2, I would get out negative 13/15. Okay, so maybe you would have seen that if you had simplified the first part and said, well, I know that maybe I can use a smaller value here. But even so, you could divide by the 2's here, and we're in good shape. So there we are, negative 13/15. And we have one more. E says 2 over x plus 3/4. Need a common denominator, so I'm going to multiply the left side by 4. So I'll have 8 over 4x, and the right side by x, I'll have 3x over 4x. When they add these together, 8 plus 3x all over 4x. And that is the end of the homework for day 4.